Today we're going to be talking about naming and writing formulas of ionic compounds. Ionic compounds are composed of metals and nonmetals that are bonded together by ionic bonds. These ionic compounds have chemical formulas, and a chemical formula is a representation of the composition of a compound consisting of symbols and subscripts. Now, many ionic compounds are composed of polyatomic ions. And polyatomic ions is a charged chemical single unit composed of two or more atoms covalently bonded. And here's a list of the polyatomic ions. These can also be found on the second page, the back side of your flowchart, that we're going to be using when we're doing naming and writing formulas of compounds. So you don't need to memorize these. We're given the formula with the charge and those names for these polyatomic ions. Now, a polyatomic ion is present if there's more than two different types of elements. So if there's 3 or 4 different types of elements, we know there's going to be a polyatomic ion present somewhere. So first we're going to be doing practice problems of naming ionic compounds, and we're going to be using the top part of the flowchart where we're starting with formula. Now, just to note when we get to this box here, if one is after the second box, we're going to use the charge of our second box. So problem number 1, we have CaCl2. First thing we're going to do is we know that this is a chemical formula because it's all atomic symbols. So we're going to box any polyatomic ions present. Well, we have 2 different types of elements. There's not going to be a polyatomic ion present, so we're going to box any elements left over. And we have Ca and Cl. Looking at our first box, Ca, we have to see if it's a metal, NH4, or a nonmetal. Well, Ca is a metal. Then looking and see if it's a transition metal, Pb, or a charge on the periodic table. It is not a transition metal. It's not in block D block. It's not Pb, so we have to do on this one. But calcium does has a charge on the periodic table because the periodic table tells us it's a 2+ charge. So we're going to write the name of the first box, so calcium. We'll continue on to our 2 options about our second box, either a nonmetal or polyatomic ion. Well, chlorine is a nonmetal, so we're going to write the name of the element with ID ending, meaning Cl, chlorine, is not going to be chlorine, it's going to be chloride. So problem number 1 answers calcium chloride. Problem number 2, we have AlF3. We're given a chemical formula, box any polyatomic ions present. There is no polyatomic ions present because we only have 2 different types of elements, so we're going to box any elements left over. So we have aluminum and fluorine. Looking at our first box, out of these 3 options, aluminum is a metal, and aluminum has a charge on the periodic table. So we're just going to write the name of the first box, so aluminum. Looking at our second box is a nonmetal, so we're going to write the name with ID ending. Fluorine becomes fluoride. Moving on to number 3, we have CONO32. We're given a formula. Box any polyatomic ions present. Well, this time we have 3 different types of elements, so we know there's a polyatomic ion. And when you look at your polyatomic ion list, you're going to ignore the charge part, just looking at the symbols and the subscripts, and you're going to see NO3 is a polyatomic ion. So we're going to box it, and then we're going to box any elements left over, so we're going to box CO. So looking at our first box is a metal, and our first box is also a transition metal. So we're going to write the name of our first box, so cobalt. But this time we're going to write a Roman number, a Roman numeral, depending on the number of our second box. Well, we have 2 outside of our second box, therefore we're going to put a Roman numeral 2 in parentheses. So then looking at our second box is a polyatomic ion, so we're going to write the name of the polyatomic ion. When you look at your polyatomic ion list, NO3's name is nitrate. So our answer for number 3 is cobalt 2 nitrate. So moving on to number 4, we have a chemical formula. So we're going to start the given chemical formula. Box any polyatomic ions present. Well, we have 3 different types of elements, so we know we're going to have a polyatomic ion. So looking at our list, we're going to see CO3 is a polyatomic ion. Box any elements left over. Well, we have Pb left over. Pb is a metal, and Pb is Pb, so we're going to write lead. And again, we need a Roman number based on the number of our second box. There is no number outside of our second box, so the number's 1. Remember, we put this footnote here. If there's a 1 after the second box, we need to use the charge of our second box. So because we have a 1 out here, we have to find the charge of CO3. That's on your polyatomic ion list. CO3 has a 1 minus 2 charge. So we're actually going to use the number from the charge for our Roman numeral. Then looking at our second box is a polyatomic ion, and the name of it is carbonate. Then moving on to number 5. Number 5, we are given a chemical formula. So we're going to have to box any polyatomic ions present, which we do have one, which is NH4. Box any elements left over, which is S. Our first box is NH4, so we're going to write ammonia. Moving on to our second box. Our second box is a nonmetal, so we're going to write the name with ID ending. Our second box is sulfur. Sulfur becomes sulfide. So with that idea, go ahead and do the problem number 6 on your own. Pause the video, and when you have your answer, press play. And the answer for number 6 is iron 2 sulfate. So now let's go ahead and do reverse. This time I'm going to be giving you your name, and we're going to be finding the formula. Now on your flowchart, find the box that says first charge, right charge of first word. You're going to write Roman number is the charge. All right, so let's go ahead and do problem number 1. We have sodium bromide. So now this time we're looking at words, first word, second word, not boxes like we did last time. So looking at our first word, sodium. Is our first word a metal, ammonium, or nonmetal? We know sodium's a metal, so we're going to write the atomic symbol, which is Na. Then we're going to write the charge of our first words. Now sodium has a +1 charge. Now we have to look at our second word. Specifically, we have to look at what the second word ends in, the last 3 letters, which is IDE. So we're going to be taking the second path. Second word ends in IDE. So we're going to write the atomic symbol of our second word. Bromide is bromine, so it's Br. And the charge for Br is 1-. So now we're going to cancel the plus and minus signs out. And we're going to crisscross numbers, meaning the 1 is actually going to go down in front of Br. So the 1 is going to move down to go down in front of Br. And the 1 in front of Br is going to go down in front of Na. So we have Na1, Br1. And lastly, we have to simplify the numbers. We can't simplify 1 and 1 down any further, but in chemistry, we never write 1s. So we're really going to have NaBr as our final answer. So moving on to problem number 2, we have magnesium sulfate. Looking at our first element, magnesium is a metal, so we're going to write the atomic symbol, which is Mg. And the charge of magnesium, which we all get the symbols and the charges from the periodic table, the charge of Mg is 2+. Now looking at our second word ends in ATE. So we have to look at our third path now. So we're going to write the charge and formula and charge of the polyatomic ion. Sulfate's on the polyatomic ion list. So when we look at the list, we're going to see that sulfate is SO4 with a 2- charge. So we're going to cross the plus and minus signs out, and we're going to crisscross our numbers. So the 2 in front of Mg is going to go down in front of SO4. And the 2 in front of SO4 is going to go down in front of Mg. So we have Mg2, SO4, 2. And lastly, we have to simplify numbers. Can we simplify 2 and 2 down any further? We're not going to simplify the 4 because we did not bring that down. That stays there forever. We can in fact divide 2 to both of these. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 and 1 we don't write in chemistry, so it's going to be MgSO4. Moving on to problem number 3. We have lead 4 sulfide. Looking at our first word's a metal, so atomic symbol is Pb. Now, this name has a Roman numeral now. So instead of looking at the periodic table to get the charge of our first word, if you're given a Roman numeral, that's the charge. Since the Roman numeral is 4, Pb has a 4+. Our second word ends in IDE, so we're taking the second track here. So a symbol and charge. Sulfide is sulfur, so S with the 2- charge, again from the periodic table. We got to cross our plus and minus signs out, crisscross our numbers. 4 goes down in front of S, 2 goes down in front of Pb, so we have Pb2, S4. Simplifying numbers. We can in fact simplify 2 and 4 down further by dividing 2 to both of those. 2 divided by 2 is 1. 4 divided by 2 is 2, so we have PbS2 as our final answer. Problem number 4, we have iron 2 acetate. Looking at our first word, our first word's a metal, so symbol and charge. Iron is Fe, but again, we have a Roman numeral, so we do not need to look at the periodic table for the charge here. We have a Roman numeral 2, so it's a 2 plus charge. Acetate ends in ATE, so we have to take our third track, write formula and charge of that polyatomic ion. Acetate is C2H3O2 with a 1 minus charge. Cross the plus and minus signs out. Crisscross our numbers. 2 goes in front of the acetate and 1 goes in front of iron. So we have Fe1 C2H3O2 2. And finally, simplify numbers. 1 and 2 cannot simplify any further. But because acetate here is a polyatomic ion, we have to put a parentheses around it because we have a 2 after it. If this number was a 1, we wouldn't need to. But because it's a 2, we need to put parentheses. And moving on to number 5, ammonium phosphate. So looking at our first word's ammonium, so we're going to write NH4, 1 plus. Our second word ends in ATE, so we have to take our third track, so formula and charge of the polyatomic ion. Phosphate is PO4 with a 3 minus charge. Cross the plus and minus signs out, crisscross our numbers. 1 in front of NH4 goes in front of PO4. 3 in front of PO4 goes in front of NH4. So we have NH4 3, PO4 1, and lastly simplify. We can't simplify 3 and 1 down any further, but see how we have a 3 after this polyatomic ion here? We have to put parentheses around NH4, but not PO4 because it's a 1. So with that idea, go ahead and do problem 6 on your own. Pause the video, and when you have your answer, press play. And your final answer is CuCr4. And that's it, guys. Thanks.